Hello, in this next series of videos, I want to go over a material from section 3.1 from the textbook. 3.1 is about sampling distributions. So what we're going to go over is a statistical inference, which we've been talking about all semester, looking at a statistic versus a parameter, sampling distribution, variability of the statistic, which we call a standard error, the importance of sample size, and the importance of random sampling. So I'm hoping to do a couple of these videos. So this would be part one, and let's keep going. Okay, just as a reminder, big picture for this chapter and really the rest of the entire semester in elementary statistics is we're thinking about getting information about a big population. So I want to get information about this big population. So what do? We take a sample. We get a small subset of that population, and we get some information about that sample. And then we're going to use that information from the sample to then say something about the population. We can't be 100% certain unless we could get information on the entire population, which generally is too difficult to do. So we use this method of statistical inference to generalize from a sample to a population. And that is what statistical inference is: drawing conclusions about an entire population based on just information from possibly one sample. Okay, new terminology from this section is a parameter is a number that describes some aspect of the population. I think the concatenation P and P, parameter goes with population. And a statistic is a number that is computed from data in a sample. So a lot of times a parameter is an idea. It's not an actual concrete number necessarily. If we think about the height of an average college student, that would be a parameter. Population mean if your population is all college students, but that might be impossible to get depending on the college and how do we define students as they drop out of class, as they add late courses, even as some young students actually grow during the semester. So parameter is sometimes more of an idea, whereas a statistic is a fixed concrete number. You could take a sample of 100 college students, measure their height, and then take an average. Okay, so we usually want to have a sample statistic and want to make it some inferences about a population parameter. So again, think population and parameter go together. Parameters are ideas about a population, and a statistic is a concrete number, a data point that we get from a specific sample. Okay, and then talk about notation. We use different notation for a lot of our different statistics: mean, proportion, standard deviation, and correlation. So just to note, the population mean is mu, it's a Greek letter. The statistic for mean, a sample mean, would be x bar. And then if we're going down the parameter column, a proportion, we just use a p. Standard deviation, we use the Greek lowercase letter sigma. And correlation, it looks like a p, but this is actually the Greek letter rho, R-H-O, rho. And then the same exact idea, mean, proportion, standard deviation, correlation for a statistic. Again, think statistic, think sample. These would actually be concrete data that we could compute. X bar, p hat, and then S and R for standard deviation and correlation. Okay, so I want to go over three examples. State whether the quantity described is a parameter or a statistic and give the correct notation. So there's three examples here, and I'm going to move over to a Word document so I could write this down. All right, so we were looking at deciding whether we're dealing with a parameter or a statistic, given the scenario, and use the correct notation. So number one is the average household income for all houses in the U.S. using data from the U.S. Census. So this is population data, comes from a census versus a sample is it for a statistic. So this is a parameter. And the notation for the parameter, we're looking at an average or a mean, is mu Greek letter mu. All right, number 2, correlation between height and weight for players on the 2014 Brazil World Cup team using data from all 23 players on the roster. So here I'm going to assume that we are talking about a population. And the population in this case is the entire roster of the team. So we could think of this as a sample, but since this says from all 23 players on the roster, we're going to think about it as a population, and population correlation parameter is that Greek letter rho, which kind of looks like a P, like a scripty P. And then lastly, number 3, the proportion of people who use electronic toothbrush using data from a sample of 300 people. Since the information comes from a sample, this is a statistic, not a parameter. And the notation is p hat. So p hat, and if you're writing a report, I'm okay with just using p hat spelled out, or the symbol p hat if you're writing it down. Okay, those are the 3 examples we looked at, and I'm gonna stop the slideshow for right now, and then on the next video we're going to look at some election polling.